All right, so I got my brother Mark back on, and today we are talking about different softwares depending on the discipline that you're going into. I think obviously each discipline has its own special kind of software that is helpful, and so we obviously aren't going to dive into every single software that's available for people out there because, this might be a 10-hour podcast episode, but we're just going to hit some of the highlights that we think are useful, things that we know about, and things we could share with you. I also think in general, there are softwares that every engineer should know. It's just kind of part of the industry that we're in. So a lot of the general tools that we'll talk about definitely going to help you as well. But really, it's up to you to find out which one works depending on the industry you're going into, which is kind of our goal here, is to help direct your attention to what's out there, and kind of if you're heading into a certain direction, to find out what's good to check out. So anyway, and I also think in general, a lot of basic tools, maybe Mark can disagree with me here, but I think in general, a lot of tools that like Google Earth, sometimes you really should get out into the field and see what's out there, because there's a lot of things that just software and doing stuff on a computer you don't really see with your natural eye.
I can chime in on that one, Isaac.
Go for it.
In fact, I have got a little field trip planned for my team, actually on Tuesday, where we're doing that exact same thing. Or the exact thing that you're talking about. We're looking at a project for an owner. It's a good sized project, and here in Lehi, Utah, and that's exactly what we're going to do. We could just use Google Earth and kind of get a feel for the lay of the land and maybe how things are laying out. But there's so much activity in Lehi, Utah right now. Construction, not only I-15 that goes through there, but there's also a lot of high-tech office space being constructed there. And so we got to get a real-time feel for where this thing's laying out, how we're going to logistically position cranes and all those things. And it makes sense for us to go out there and walk the job.
Yeah.
See how it's laid out.
I should put a big asterisk on there, because that could really bite you in the butt if you don't take a field trip. In my own industry with transmission design, you could play around on a computer all day, but until you actually go out and see a stake in the ground and see where stuff is going, you don't see it all. You don't see the sewer line that you could be hitting, or other issues that are in the way, or clearances to things like that. So, and you gotta get out there. So having said that, let's dive into some software. So all right, there's our caution for everybody.
There's your warning.
So Mark, let's talk about just general software overall. What do you think is good for an engineer to know about?
Yeah, I think it's good to have a good, working knowledge of AutoCAD. I mean, that's kind of the baseline drafting software, that you're not pulling out your graph paper. You don't have a drafting board anymore, where you're actually laying things out. If you're someone like me that works in the structural end of things, you're trying to make sure dimensions are compatible and things are laying out properly, whatever you're designing. And so Autodesk is really just an invaluable tool, because everything can be laid out to scale. Everything that you've sized, that you've calculated, any structural member can be, quickly put down and laid out, and you can make sure everything fits. Obviously, the next step up from that is Revit, which we'll talk about. But that's one of the big ones I say is one of those base pieces of software that every engineer should have at least some kind of working knowledge of.
Yeah, and I believe every engineer has to take a class on that. So, if you don't use it, you kind of lose it. I'm not a heavy AutoCAD user right now, but I still get involved with it. But that's kind of a baseline software to know for.
Yeah, and I use it every day. I use it like every day, man. It's like when I have something, my brain doesn't work now because I've used it so much. Like it's like I need it for my brain to start working and laying things out and making sure everything fits. It's just like, I don't know. It's just like a go-to piece of software for me.
Cool. Yeah. So Autodesk. What are the other ones? we've talked about some of these PDF softwares like Bluebeam. A lot of people were using Adobe, but Bluebeam, if you're not familiar with that, is just a really helpful tool for the industry. I use that. I use that all the
Yeah,
time.
and Bluebeam has been kind of it's been nice because it's more of a, I'd call it more of an intuitive type PDF management tool for marking things up, and you can
Measuring.
measuring take. I mean, it's kind of it's a cool piece of software. It's a nice tool.
Yeah, if you haven't checked that out, definitely do. But and then in general, your general Microsoft tools, which you're gonna go through school and understand if you're not familiar with those already. Google Earth is definitely a must, I think, which is a fabulous tool. And I think also a little bit of ArcGIS, which is also a class when you're in school at a university to take. And I think a lot of people might brush that class off because it's not maybe the specific focus you're going to go into as an engineer, but it is a tool that's used quite a bit in all industries to really display information in a really neat way. So
Yeah.
that's kind of our general list. Do you have anything to add to that, Mark?
No, I mean, once we get into construction, I'll have some more comments. But yeah, I think that's a pretty good general list.
All right. Well, let's dive into construction. What do we have in here?
So construction, the big thing with construction is you've kind of got this group of takeoff software, right? So the construction guys, once a design is produced, and it doesn't matter if it's a commercial building or if it's a bridge or a roadway project, there's quantities to be taken off, right? You got cubic yardage of dirt, you got cubic yardage of concrete, and those quantities form the basis for the estimate, right? So you got to know how much, how big things are, and how much tonnage, how much cubic yardage, how much square footage is in the job, so that you can put a price on it. And so there's a bunch of takeoff software that exists, and I would say the forerunner and all that is Plan Swift. There's on center software has another set of takeoff software that's pretty prevalent out there, but that's the big one is Plan Swift, and there's others, of course. And then once you get through a takeoff, then you want something that you can estimate with, right? You want to be able to plug in all those quantities into some kind of a tool that helps you estimate your job. And the big ones in transportation is HCSS Heavy Bid is a big one. There's one called B2W. It used to go by Bid to Win, but now they just call it B2W. I guess they figured Bid to Win was a little cheesy of a name, but and those are the big ones in the transportation industry, or the heavy highway and civil construction industry.
Interesting.
And they're geared towards moving dirt and that kind of stuff, drainage, pipelines and those kind of things. And then on the commercial side of things, there's Sage, which used to be called Timberline, Sigma, ProS. There's software, estimating software that kind of just specializes into that commercial construction realm. Some of the others. So what we're talking about here is first we start with the estimating software, and then you move into, you start with the takeoff software, then you move into the estimating software, and then you move into the project management software.
Your Primavera.
And so, and the scheduling, that's part of that. So your Primavera P6s, your Microsoft projects, your BIM 360s, which is an Autodesk product, is kind of a project management software. Procore is a big one. So there's kind of these big three segments of in the construction industry of software that's out there, and then there's some overarching software that, I mean, there's companies that are trying to incorporate the accounting, the estimating,
all All
and the
wrapped
act
up.
and all the project managers all wrapped up. Nobody's kind of really tackled that sufficiently, in my opinion, but it'll probably happen one day. But
So what's your thoughts on somebody, I'm just thinking about an engineer that, wants to focus on learning one of these. Do those skills translate to the other softwares? Are they easier to pick up? Because
yes,
to learn all of these seems impossible, but if you learn one, maybe they bleed over into others.
they do. They do. So, like, if you were heading into the construction industry and you were focused on heavy highway and civil, and you jumped in bid to win, or B2W as they call it now, that would definitely translate into heavy bid, and you could transfer pretty seamless across platforms. But estimating's estimating. I mean, to be good at it, you really need to get a lot of experience. But the software to tackle just the software, if that's what we're talking about, yeah, learning any of these is going to help you across all the platforms for sure.
Cool. Well, anything else to add to construction?
No, I mean, we talked about Bluebeam. SketchUp is a nice one. SketchUp's kind of a stripped down BIM modeling software, so it's not as big as say an Autodesk Revit. But man, for hoisting plans and those kind of things, we got big girders that we're hoisting, and we got to create a hoisting plan for that stuff. Man, SketchUp is nice because you can scale really quick 3D models in SketchUp.
That's
So
nice.
that's a good one to learn.
And that one, is that one free? I can't remember. All of these have a free
Yeah,
option,
they all have.
I'm sure.
SketchUp is
Trial.
there's a trial, but SketchUp, in fact, just barely went to a subscription-based model, which most software is doing these days. But yeah, you can get a standalone version, but I think they're going subscription-based now.
Cool. All right. Well, let's dive into our next discipline, which is our geotech arena. Obviously, I think there's a plethora of softwares for geotech, depending on what you're analyzing and what you're getting into. And I think in general, though, you have various software for foundations. I myself am familiar with using what's called LPile, and we use that to design some of our deeper foundations or for the transmission structures. But we've listed here others like Plaxis, Soil Vision, Open Ground, Site, and there's various software for seismic software. There's a really neat website I found actually called Geotechpedia, geotechpedia.com. And there they list all of the softwares that they can find for geotechnical engineers. And it is pages and pages and pages of geotech software that you can check out. I don't know what to say is like the most popular or the most used. It seems like there's just a lot of different applications for different things. But what are your thoughts on these geotech ones?
I the only geotech that I do personally, sometimes I have to design retaining structures, soil nail walls, soldier pile, those kind of things. And I don't use any of those. I got a package. I use StruCalc for a lot of those, and we'll talk about that when we get to the structural software. But I don't use any of those. My stuff, of course, is. I mean, I'm coming from a more of a structural perspective on that.
Right. I just know that in general, there is a software for basically any application in the geotech world. And we'll try to link this resource, but it's called geotechpedia.com. If you go check out the software, I'm telling you, there are pages and pages and pages of different softwares you can check out for geotech. So cool. A ton of them. What about, let's go into water resources. In school, it seems like what they mainly have you focus on, at least when as I've been going to school, has been HACRAS and HEC HMS. All of these softwares are used basically to model groundwater or surface water or floodplain modeling. Then there again, there's quite a few softwares under water resources. But for like school and for what you use even after school, I think that Heck RAS and Heck HMS are very popular softwares.
Yeah, I think they're the dominant
know.
ones. Yep.
Do you know of any others for water resources or anything under
Those are
that falls under there?
those are the 800-pound gorillas. I don't know of others specifically.
We need a water resource engineer to get on, and
I know we could use their input right now.
they'll give us some negative feedback.
Probably.
Again, for water resources, that Geotechpedia also has a ton of options for water resource softwares for water and groundwater. And I could sit here and read you a few pages,
Yeah,
but
and
I'm
I
not
can
going to be familiar with them.
Neither am I. And I can say Bentley offers a ton of those kind of packages. They're a good resource too to kind of check out.
Yeah, just a quick sample. They're showing Mike Flood, Precision 3D, Hydro, Adaptive Groundwater, Aqua 3D, all kinds of stuff.
Yeah.
So go check that out. We'll list that. Let's jump into structural then. This is kind of Mark's forte. So
yeah,
what do you got here?
What's cool about the structural software is it's kind of it's developed, I'll say. So the Autodesk, their AutoCAD used to be the workhorse. Now Revit has completely taken over structural design, and so our Autodesk Revit is what is developing the BIM, right? The building information model that is really I mean that's what's used nowadays, and it's a nice tool. What they can do with that now is, in the old days when you had to draw everything, AutoCAD had some 3D capabilities, but the information wasn't really in the core of the software. It wasn't really in 3 dimensions like it is in Revit. And so what's cool about that is that you're used to looking at cross sections, and you can look at plan views on projects, but what they're working with Revit is a complete 3D model. And so they just go through and they define where they want these views, what plan views they want to define, what section views they want to define. And it's really easy for them to define these locations, and then it just compiles all that for them and creates a set of contract drawings. And it's a really slick tool.
I'm not terribly familiar with all of the softwares. Is Revit doing a structural analysis, or is it just for drawings?
Right now, it's primarily just for drawing, but that is changing as well. Autodesk is working on an actual structural design component to Revit, and my belief is that eventually that will probably take over the standalone structural analysis packages, because it would be such a cool thing, because you're building. Because with the other structural software, like if we're talking about SAP, 2000, RISA, STAD, any of these other high-end structural packages that you can buy, you're really building the model within that structural software and doing the analysis separate from the tool that you use for the design and the layout. Well, it just makes sense to merge those two together eventually, and Autodesk is working on that. And who knows what ends up happening, but I can just foresee that being too much of a convenience.
Yeah, I don't see why you wouldn't.
You're designing and building your model, and bam, after that you do your structural analysis, and the whole thing is put together in one package. I think that's a good deal.
That's cool. So for people that don't know, what are the top kind of analysis softwares for structural? You talked about them, but I don't think people that just hear these names, they don't know what they do.
Yeah. Okay. So there's a company called Computers and Structures Incorporated, CSI. They're the ones that develop a suite of software. One of the most prevalent ones that they have is SAP 2000, and so it's a software that will do Everything. It's a finite element type analysis software that once you put your model in there, I mean, it'll analyze everything, everything. It'll give you your obviously the simple stuff is your gravity analysis, but any lateral analysis that you need to throw at it, it'll do that. Plus, it'll also do performance-based design. So usually when we talk about structural design, we're talking about design that's prescribed by the code, right?
Mm-hmm.
Everything's got to adhere to the structural codes, whether it's, ACI or AISC or the governing codes, IBC, of course, but everything is prescribed by code, what can and can't happen. Well, on a performance-based design, an owner can dictate what level of performance he wants his building to perform at. If he wants like his building to just have life safety after a seismic event, that's basically what the code provides for him. But if he wants his building to be usable after a seismic event, then this software can analyze those types, I'll call them those levels of analysis, which gets really deep. I mean, some of those performance-based designs, I mean, back in the old days when AutoCAD used to, when I started, they were working with release 14, right? And I remember hearing some of the old drafters are like, yeah, when we'd hit render on our drawings after we were done detailing a certain area of a building or whatever they were working on, they had to go to lunch and let the thing render while they were at lunch, But now obviously computers are powerful enough that none of that needs to happen anymore, and it's just instantaneous. Things can be produced on a 3D model or whatever pretty instantaneously. But sometimes now when they do these performance-based designs, the calculations that have to happen, and using programs like SAP 2000, I mean, it takes that long now. Like it's software that's taxing the hardware.
When you say it takes that long, you mean they're going out to lunch again?
Yeah, and it takes hours for it to analyze the model, and it's just it's crazy the level of detail now that they're getting in their structural analysis. But yeah, SAP 2000, and then there's a lot of packages, software packages that resemble that are competitors, but.
And I just to note, I don't think it's just the structural arena that also is getting a little more detailed and thorough in their analysis too. I think it's every software that you have available. Obviously there's updates to them. So
yeah, it's just interesting to me that there's actual software that's overcoming the capabilities of the hardware anymore these days. You know what I mean? It's like, we got all the computing speed we ever could dream of these days, and there's actually some analysis that
chugs it.
Yeah, it really taxes the hardware, So that's interesting to me.
Cool. Well, that's helpful. Any more on structural softwares?
And then there's other subgroups. I know in my market that I work in, there's a lot of RAM is a big structural package that's used for structural concrete design, and that's a Bentley product. There's STAD Pro. They're also Bentley products. RISA, is another one. And then AutoCAD has got this other package that kind of goes on top of Revit that's called Navisworks. So Revit generates the model, and then Navisworks does kind of the clash detection, and it's really the tool that analyzes the model. That's another one that's pretty prevalent. But with all of that said, when it comes down to what I use personally, I mean, I don't get into that much detail. I'm not doing any performance-based design and those kind of things. I'm a an intercalc, a StruCalc kind of a guy. Those handle 90% of whatever I need to do. So
let me ask you this, and this goes with all softwares, is as we head more into like a world where software is used for everything, how important is to know what it's doing, how it works, and kind of the background, the theory behind it all, because eventually you kind of get used to just using the software all the time. But as an engineer, you need to know what's going on there. What's your thoughts on that?
Well, I'm kind of old school in the thought that someone needs to know the basics. You need to know if what the computer is spitting out makes sense. Um, I got a couple newer engineers that are working with me that struggle with that a little bit. That even though the computer is telling them that there's a certain load in a shore, for example, if we're doing a reshore design or some kind of false work design. I always try to draw them back to the actual dead loads that are in the structure, that the shores are actually seeing, quote unquote, and seeing if what makes sense intuitively as you check I have them check on paper with a hand calc what the computer is kicking out, just as kind of a double check. If the bridge deck that I'm supporting is 8 inches thick, then you can kind of figure out what a tributary area is going to be for a certain shore, for example. And the load in that shore that the computer calculated better be pretty close to what you get with your hand calc, or something's off.
Yeah.
And
Okay.
so I try to steer them in those kind of directions for sure.
And I think that's good for everybody to understand that, we get so dependent on the software sometimes that it's still important to kind of understand what's going on behind the scenes and kind of do a sanity check on some of that. So
Absolutely.
let's dive into transportation then. And what's some of these transportation softwares we listed out? What do you think some of the most popular in there?
So I see AutoCAD Civil 3D as a big one. I got surveyors that work for me that's their kind of go-to package for laying out and creating models for grading and different things. MicroStation,
Yep.
which inroads. I got guys in my office that use that, and open roads too, for a lot of our design build pursuits, where they're creating models, embankments and alignments for roadways and those kind of things, and they're able to generate quantities and stuff that help us kind of get a feel for where pricing needs to be on our design build jobs. Use that quite extensively, and we actually work with transportation design firms that use that software extensively too, to lay out their jobs. So the other ones, Isaac, I'm not as familiar with, but I know.
Well, neither of us are diving into the transportation engineering world, so those out there will have to forgive us if we've missed some of yours.
Yeah, but again, the king of the transportation design software world is Bentley again. I mean, they're the ones that have kind of the most prevalence, and probably the most sophisticated stuff that I've seen.
And with
That's
transportation, they probably do fall into a couple categories. One's probably traffic related, where you have simulations,
correct,
transportation planning, and then pavement analysis and probably design. So there's a long list of softwares, but I think Mark kind of just hit it on the head with Bentley being probably the big elephant in the room.
They're the 800-pound gorilla on that one.
Okay. No, I think this is a good list of software. I just would probably add, or maybe you can talk to this, but as an engineer, maybe that's just starting out or knows what kind of area they want to get into, what's the benefit? What do you think they should be doing, in either to prepare for a job or to give them a leg up in the industry?
Yeah, I would say if you know what area of civil engineering you're going to specialize in, if you're gravitating towards construction or geotech or water resources or structural, whatever it is, learn about the firms, if the design firms or the construction firms that you may go for. You can find out what software they use, and just do a little homework. And if that's the direction you want to go, just start using some of them, start practicing on them. And even if you're just using software that's specialized in any of our civil engineering disciplines, I mean, like we talked about before, they're going to be the skills that you learn or the exposure you get in one software is going to translate pretty well into another one if they happen to be using a different software package. But you're going to have a leg up from just somebody who's maybe just fresh out of school and just trying to figure things out. If you know the software, at least you've had some exposure to it, man. You got a leg up, I think.
I agree. I've interviewed quite a few people just in the transmission engineering world, and if they have any experience whatsoever in the software we use, I mean, you're immediately, head and shoulders above the next guy.
Yeah,
so
you're at the head of the line.
Yeah. So if you have any inkling of the industry you want to go into, find out the software. I'd recommend getting a free trial version and just becoming familiar with the layout. If you can model something really basic, that might be helpful, but just become familiar with the tools that people want you to know.
And absolutely. Yeah.
A leg up.
Leg up.
So anyway, I think that'll do it. Great tips, great softwares that we discussed. If you guys have any comments about any of this, feel free to email us. You can reach Mark at civilengineeringacademy.com and Isaac at civilengineeringacademy.com. We'd be happy to answer any questions you have about any of this. So, Mark, thanks for joining me again, and we'll probably see you on the next one.
You bet.
All right, bye.